Hello and welcome to the EMC live stream Thursday edition. With me today I have Anna. Say hi, Anna.
Hello.
And for any viewers joining us, say hi to Anna as well in chat. We'll pass that along. Today we're going to get warmed up with some warm-ups. Let's start off with one you might be familiar with, Anna, but our audience might not be. We used to play, I think, this in grade Circle 5 a couple years ago. So this one's called Factor Path. Do you remember playing this before?
I don't think so.
Don't think so. Okay, our goal is to find the longest and shortest path that contains all the factors of a specific number. You can choose that number. So in this example, they've chosen 12 and they have listed out all the factors 1 with 12, 2 with 6, 3 with 4. All the factors of 12 occur along this path. But the order doesn't matter. So we want to find the longest and shortest path. And here is our actual puzzle. So, give you a shot at looking at it first, see what you see, and then pick what number you'd like to go with. You can draw as well on Zoom if you like.
Yeah, I know. Thank you.
No problem.
Um, uh, we can do for the number 20, we can do
Mm-hmm.
1 and 20, 4, uh, 10 with 2, uh, 4 with 5, and that gets us to the answer.
That is one of the possible paths. How long is that one? 1, 2, 3, 4, 5, 6. That's 6 long. Is it the longest, though? Is there another one that's longer? What else do you see? Hello, viewers. Feel free to say hi in chat.
Um, let's see. We can do 1, 10, 15, 2, 3, 36, 5, and to the exit from 30.
For 30, we have all those factors. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Awesome job. That one is 8. That's now the longest. Can we find the shortest path? What would the shortest path have to be? What length would it have to be?
Mm, mm. The minimum of length that anything would have to be would be at least 4.
At least 4, because we have to go through 1 and 5, and then we have to get somewhere in row 2 and somewhere in row 3.
Yes. If we can go here for a four square path.
Four-square path
for
with
the number
10.
10.
Yeah, exactly. 1 times 10 or 2 times 5 gives 10. So the shortest path was 4. There is another shortest path. Can you see it?
Um,
Yes, yes. 7 and 35. 5 times 7 is 35, and they're both prime. Awesome. Okay, we've got someone here with us. Say hello in chat if you can. If not, we're ready for our next warm-up puzzle with Anna. We have to move one matchstick to make this true. 7 plus 6 equals 5. When we say move, we mean don't remove. It has to be a move.
uh, I mean, technically, if we move this matchstick here to make not equals to, that does make the equation correct.
That is correct. That is one way. We can always make a not equals. There is a way without not equals, though. Can we find that one? What can I turn 5 into by moving one around?
You could turn it into 3, 9, or 6.
What about 6?
It can be turned into 9, 3, or 8. And this could only be turned to 1. And this can be turned to a minus.
Mm-hmm. And we also have one more here.
Oh,
If I take this away.
and 5, yeah.
Okay, so do we see...
Oh, we can make 1 plus 5 equals 6.
Okay. Well, I can only move one
Oh,
matchstick.
wait,
Which
no.
stick?
Right.
With 2 matchsticks, absolutely.
Yeah.
This one's
That
tricky.
wouldn't even work with 2 maps.
Because we could go 6 and then use the European one. Yeah?
I mean, I guess.
Nothing wrong with the European one. We can use the European one when we want to.
Yeah, I know.
The one I'm thinking of uses negative numbers. Do you want to see it?
Yeah.
I can split this 7 into a
Mm.
negative 1. Negative 1 plus 6 is 5.
Hmm.
Okay, one more for you. 1 equals 2 plus 0, of course. This is true. This time we got to move 2 matchsticks.
So we can move this matchstick here and this one here to make 7 equals 2 plus 5.
Absolutely. 7 equals 2 plus 5 is one of my answers. Another one only uses these two from the plus sign, but in a clever way. Hello, viewers. Today is 789 day. We've got Anna K with us. Feel free to say hi in chat.
And then we did 2.
This one is a little hard.
Oh, to the power of.
2 to the power of 0.
And we could always go with a good old not equal to.
Always can go with the not equals, of course. Many choices there for the not equals. Okay, today now we're going to have our chat getting to know Anna, getting to know a little bit more about our guest. She's a student with us, but she's one of our favorite students. That's why we called her in here. So, Anna, how are you today?
I'm doing good.
Excellent. So, Anna, why don't you give us a little bit of your history at EMC, what you have taken with us before, and maybe who your favorite teacher is? No pressure.
Um, so I've taken the, I forgot what it was called exactly, but like the pre-algebra one class or um I forgot what it was called. And if I remember correctly, halfway through the year, I got put into the like actual algebra class, algebra A,
Hmm.
because I was bored, if I remember correctly.
Yeah, yeah. Sometimes
And
if
I've
if you're bored, you can just bump up at EMC. It's totally normal.
and uh and like this last year, I've taken the algebra B
Hmm.
class here.
Yeah. How did you find all those classes?
They were fun. I met a lot of fun people.
Hmm.
Oh, and
Do
you
you?
asked about my favorite teacher?
Yeah.
Probably you.
Probably me.
Yeah,
You don't have to say that just because I'm here with you. You can say Stephanie. You can say somebody else. That's fine.
you were the funnest.
Okay. Well, I'm glad to hear it. Um, okay, Anna. So maybe a little bit about you. What are some of your hobbies? What do you like to do with your free time?
So I like art a lot. I like to draw and I like to make stuff out of cardboard. Um,
Hmm.
I've made some helmets
Very cool.
and I've made some swords.
Very nice. Are they part of a costume for Halloween or anything, or you just like to make them for fun?
I sometimes make swords or other cool stuff. for my friends. Um, Sometimes I make them with the hopes that I will sometime be able to use them in a costume.
Mm-hmm.
Um, and sometimes I make them just for fun because I'm bored.
Yeah, that's normal.
Um, I A lot of the stuff I make is references to shows or other media I've watched. This is an example. If any of you in the audience know Jujutsu Kaisen,
Mm-hmm.
this is a reference to that.
Dice with eyes.
Yeah. In the show, it's called The Prison Realm. So,
The prison realm. Okay, so
yeah.
she's got a prison realm in her house. Don't mess with Anna. Okay, Anna. What about books or movies? What are your favorites in that area?
Um, I like anime. I watched Demon Slayer, My Hero Academia, Jujutsu Kaisen, and I'm currently attempting to watch One Piece. It's log show.
Yes, for those who don't know, there's like over 1,000 episodes at
Yeah,
20 minutes each.
and they're still making more.
It's the longest running anime by like a long, long amount. Well, that's exciting. Good luck with that. I hope you can finish it.
Thank you.
It's a big task. Okay. Um, do you play any sports or have any outdoor activities you enjoy?
Um, I used to do swimming a lot. I was on the swim team, where I live.
Mm-hmm.
Um, that's about all I do. I sometimes go for runs.
Mm-hmm. And you said you had some art, love of art. Do you have any pieces of art you wanted to share? I think you had
Um,
one ready earlier.
I do have some drawings. Um,
Remember, we're aiming at
yeah,
the age group we're aiming at.
yeah. I have some Jujutsu Kaisen drawings.
Mm-hmm.
Yeah.
Very nice.
Do I have any other cool drawings? Not that I can find right now.
That's okay. Those were nice. Thanks for sharing.
Oh, I found another cool one I'd like to share.
Very cool. You could like use that as an avatar. Just tuck it in your shirt. Very nice. Okay. And what's your favorite holiday?
I gotta say Halloween because like I like making stuff for costumes,
Oh yeah,
and
yeah.
Halloween is one of the few times where I could actually get to wear some costumes that I could make.
That's true.
Christmas is also cool. I like presents.
I think everybody loves presents, giving and receiving. Just seeing the smile on people's faces. Awesome. Okay. Thanks for sharing, Anna. Did you have any questions for me? I just put her on the spot. She doesn't know. That's okay.
Uh, I um I do have one question. Is the Sector Dinos your favorite blocket mode?
Is which one my favorite? Look at
Deceptive Dinos?
Deceptive Dinos is my favorite to teach math with because um, because for those who don't know, Deceptive Dinos is one game where you can cheat. You can look under the rocks basically and see what you're going to get so you can pick the best thing. But if somebody catches you, then you lose, I think it's half your money and they steal it from you. So it's risky. But the best things are multipliers because the multipliers keep multiplying each other. Um, so the more multipliers you have, the more points you get per item. So it's actually the most efficient strategy is to cheat for the first half of the game or more to stack up as many multipliers as possible. And you don't care how many people steal from you at all because the first one you get will be more than they ever stole from you because you're only going for multipliers. So it's kind of and because they're checking on you, they didn't spend as much time searching for multipliers. So I would say it's my favorite one to teach uh, students a lesson. I always just like destroy the kids on the first day that we play Deceptive Dinos together, and then they look at me like, "How did you get such a huge score?" And I get to teach them about the power of compounding multipliers.
I use this strategy a lot. It works.
It works. How to win at Blooket with Mr. Andy and Anna. The answer is to cheat the legal way. You're allowed to cheat in that game. That's part of the mechanics of it. That was a great question. Okay, let's get over to quadratics today is our topic today. So we warmed up with some factors of regular numbers, but have you ever factored a quadratic before?
Is that a question for me or the audience?
Yeah, both.
I have.
You have. Audience? Anybody? Well, we're going to learn how. So first we're going to play a little mini game called Sum Products. Okay? So we have to find two numbers that sum to the green number and multiply to the blue number.
So, uh, personally, the instant I see 48, I think of 6 times 8 is 48.
Mm-hmm.
And that is exactly the answer, 6 times and 8, because those add to 14.
Perfect. So 6 plus 8 is 14, and 6 times 8 is 48. That's the name of this game. Okay? If anybody's playing along in chat, see if you can get the third one before we get to it.
Well, that's gonna be hard for them because I already know the answer to this one because
Uh-oh.
the only factors of 21 are 7 and 3, not including 21 and 1. And
Yep.
because it has to be negative 10, make them both negative because negative times negative is a positive.
Negative times a negative gives a positive, but when I add them together, I get slightly more negative. Okay.
Uh,
No one has beat you yet, Anna. What do we need for here? Add to 19,
so
multiply to 18.
what are the multiples of 18? 3 times 6? Wait, no. Yeah. Yes.
3 times 6
Or
works,
1 and 18,
or 1 and 18. Which of those
which
adds up to 19?
1 and 18.
1 and 18. Okay, so we call these sum products. This is just a little mini puzzle game. But we're going to show you how it relates to quadratics now. So what is a quadratic? Do you remember, Anna?
So it's. A type of function.
Type of function? What form does it have?
It's like a U function.
Yeah. When you graph it,
One of these, not both at the same time.
it kind of looks like a U or an upside down U, but it doesn't become parallel like the letter U. They keep going out a bit. They bend away from each other forever. We call that shape a parabola. Well, I meant what was the algebraic form?
Oh,
That's okay. I wasn't specific enough. How would you know? So you're right there, a function where I can put x inside of it and I can get something that has some numbers a, b, and c here. Okay, we call the first term with the x squared the quadratic term. What do we call this term here, Anna?
the linear term.
Why is it linear?
Because only has x to the power of 1 next to it,
Mm-hmm.
which uh, linear functions, the basic linear function, would look like y equals x or some x with a constant sometimes.
Yep. Y equals some amount of x plus a constant. So if this was gone, this would be a line. So that's why we call this a linear term. And finally, we have our constant term. It has no variable in it. It's just a number. So to factor quadratics, we're going to look at this form. We have 1 for A, we have 7 for B, and we have 10 for C. And to factor them, we play our minigame. We say what number adds to 7, what pair of numbers adds to 7 but multiplies to 10, adds to the middle, multiplies to the end. And then we use those numbers in brackets with our x's to get our factored form. You remember doing this a lot?
Yeah,
A lot, a lot?
yeah.
That's good. So x plus p times x plus q, if we expanded the left-hand side, we'll have x squared plus px plus qx gives us p plus qx plus p times q. So that's where it comes from. So we can play this game again to factor. This is our b, and this is our c. So what would the brackets be for this one?
So 5 and 3 to make positive 2 make the 3 negative. So it would be x minus 3 and x plus 5.
Exactly. And our original quadratic would have been x squared plus 2x minus 15. Okay, if you're watching in chat, see if you can beat us on the third one. We'll be on the second one for a second. Hey, what would our quadratic be?
8 and 8, 4 and 16. that's the one.
That's the one.
Make 4 negative, so we have 16 and negative 4.
Okay. And the
So x minus 4 and x plus 16.
awesome. Super job. Now we've got an x squared plus 12x minus 64 that we've factored to give us x minus 4, x plus 16. Last one. See if anybody can beat us
So
in chat.
5 and 6, first factors that come up, make both of them negative because it's negative 11 and negative 5 and negative 6.
Which makes our factored form. You go ahead.
X minus 5, x minus 6.
Excellent. And our quadratic form would have been x squared minus 11x plus 30. Okay, so if you're ever having trouble factoring, try playing this mini game here, where you need to find something that they add up to and something that they multiply to. That was our little mini lesson on quadratics. I hope you enjoyed it all. Now we'll be looking at some competition style problems. You ever participated in a competition, Anna?
Yeah, I have been in many math competitions.
What's the most recent one you did?
I don't remember. I believe it might have been an EMC sponsored one. I don't know. Or
Noetic?
like, I think so. I don't remember. Either the Noetic or the Kangaroo.
Yep, those are the main two that we do. But we also we started encouraging more people to do this one as well. The AMC, American Math Championship,
Hmm,
or American Math Competition. I forget what the C stands for.
who knows?
But let's see if we can solve this one, Anna. An integer is assigned to each vertex of a cube. The value of an edge is defined to be the sum of the values of the two vertices that it touches, and the value of a face is the sum of the values of the four edges surrounding it. The value of the cube is defined as the sum of the values of its 6 faces. Suppose the value of a cube is 324. What are the sum of its vertices?
Do all the vertices and the stuff have to have like the same, like this vertex would have to be the same as this vertex and
They could have
so
different
on?
values.
They can have different values.
Yeah, they could have any value.
Hmm.
What do you think we should do to start this one? A lot of thinking going on that face. Okay, so each vertex has an integer.
So it's 0 through 9, right? No, that would be 2.
Integers could be anything.
Yeah, that I was thinking of digits. Or I
Yeah,
was thinking of something that could make this easier, probably.
Well, it doesn't tell us we can't repeat. We just have to solve it. So we could consider all of them to be the same if we wanted to.
We could.
What if they all had the same value x?
Then there's one, two, three. I forgot a minute. Uh, one, two, three, four. One, two, three, four.
And how much is each edge worth?
It's worth 2x, and then the this would be worth 4x.
For the face?
Well, yeah.
The sum of the values of its four edges.
Oh, right. I was thinking about it just how an area would be, or not even area, like half area, half addition.
It's okay.
Um, so then
So looking at the front
2x,
face, yeah,
2x, that would be 8x.
8x per face.
And then there's 6 faces, so there is 48x.
8 times 6
If
is 48x. So what should I do with 48 and this number?
divide 324 by 48, and that gives us 6.75.
Hmm. What does that tell us?
Not all of them are the same.
Not all of them are the same, because if it was all the same, we would have a nice round number here, but it's not an integer. So another way of thinking about it is how many times will, just looking at it from one vertex's point of view, pretend all these other x's are gone.
It contributes to 3 faces.
How many of these show up in the final sum?
If we have x, 6x.
6x's. 2 for this edge, 2 for this edge, and 2 for this edge.
Oh, wait, no,
Right?
3. That's assuming this one would be the same.
So there's 3 edges, but each of those edges will have 2 numbers in it.
So there's 8 vertices. There's 3 of one vertex. There is 3 of another vertex. Oh,
Not
no,
not quite 3. What about this face? How many x's end up on that face?
2.
2 plus 2.
Well, like this would not be like 2x. Like if this was a and that was x, that would be ax, not x,
Mm-hmm.
or not 2x. But
Right. This would be ax.
So if we have AX and AX, there would be only two X's
Two
here.
X's for that face. What about for this face?
Also two X's and also two X's.
Excellent.
And
So how many
that would
total
actually
X's end up in the
that
bottom
would
in the
actually
total
make
thing?
six X's.
Just like you originally thought. You originally wrote down 6X and then changed your mind to the 2. So there will be 6X's in the final total here. How many A's will there be?
Also six.
How many B's?
Also six. And
There's 6 of every
so on.
vertex. So what should I divide this by now?
Six.
Divide it by 6. And I will get the sum of the
54.
numbers. 54 is the correct answer. Great job, Anna. Okay, I like this one. It's a tougher one. Inspired by Math League. A goat is attached to a fence post by an 8-meter long rope. She can walk wherever the length of the rope allows, but she cannot jump over the fence, the red line, or enter the house, the triangle. What is the size of the area the goat can reach? Give your answers in terms of pi.
So uh on this side, the goat can reach a semicircle
Mm-hmm.
with the radius of 8.
Okay, so a semicircle with radius 8.
So if we're looking for the area, that is 8 squared on pi.
That's for the whole circle.
Yes, and then divide that by 2 to get the semicircle, or you can multiply 4 times 8, because I find that easier than multiplying then dividing,
Mm-hmm.
which is 32 pi.
32 pi for the top. I agree.
Then whenever the goat would reach here, it can go on another semicircle, now centered around this point, with it being instead of 8, it's now 6 meters for the radius,
Well,
which would be like here,
yeah.
assuming it was a circle.
Yep. We can't quite fit a perfect circle on there.
So now that is 3 times 6. I divided 6 by 2 already for the semicircle,
Mm-hmm.
times pi, which is 18 pi.
18 pi on the bottom half. But wait, there's more.
Yep, because this is a um, equilateral triangle, so this makes this 2 meters as well.
Mm-hmm.
And because the cow cannot go in the house, there is this 120-degree angle where the cow can roam, or the goat can roam around.
Yes,
It's
I
not a
was going
cow.
to say that's a goat. It's clearly a goat. Okay,
So
so we have how much of a circle is that?
that is a third. If the best way to do any sector, what what's the part of the circle called
Yep, the sector.
sector? Is 120 for in this case.
Mm-hmm.
The the general would be the weird O from the Greek alphabet. I am no,
Theta.
I don't remember. Theta, thank you.
No problem.
Over 360 because that's the whole angle of the circle, one full
Mm-hmm.
rotation, and
Excellent.
the theta symbolizes like the given angle.
Very well
Um,
explained.
this number, which is one third in our case,
Mm-hmm.
times the area of the circle, which because this is 6 meters and the row is 8 meters, it would give us 2 meters left over, so that's the radius. So we have one third times 2 squared pi, which is 4 thirds pi.
Excellent. So we have 4/3 pi for this little chunk here, and we just got to put them all together. 32 plus 18 plus 4/3. 30.
Those numbers actually add up quite well.
They do.
This gives us 50, 50 and 4 thirds, or technically 51 and 1 third pi
51 and 1/3 pi what?
meters, right?
Close.
Oh, square, because area.
Meters squared because we got the area. Super job. Did you like that one?
It was fun.
Is it because of the goat?
Yeah.
It's because of the goat, isn't it? Goats make things fun. Okay, over to our next problem. Ivy has a convex quadrilateral piece of fabric whose sides have integer lengths. The perimeter of the piece is 32 centimeters, and one of the sides is 6 centimeters long. What is the greatest possible length of one of the other sides of this quadrilateral piece of fabric?
So,
So, what possible cases do we have?
quadrilateral. So it can be any four-sided shape,
Mm-hmm. Yeah, it doesn't have to be this shape. It could be anything.
even though I actually drew that shape. That's
Yeah,
actually funny.
you mirrored that really well. Mirror
Um,
rotation.
well, the first thought that comes to mind is that one side is 6 centimeters,
Mm-hmm.
obviously. Two others are both 1 centimeter, and 32 minus 8 gives us 24 centimeters.
Now, is that possible?
Apparently not.
Why not?
Let's see.
If I had 61124, what's wrong with that?
Well, that would not, the Pythagorean theorem doesn't work.
Correct.
Um,
We don't
right.
have right angle triangles, so
Oh, not Pythagorean theorem. The other thing about triangles
the other
that
thingy about triangles.
where if you add up any two sides, they must be gr- greater than the last side. Yeah,
Greater than or equal to?
or equal to.
No, not equal to. I tricked you.
No.
If it was equal, they would
Yeah.
just be they would fall flat and land on
Yeah.
each other, and it would just be a flat little sandwich. You'd have
Okay. Yeah.
right. Okay.
Uh-huh.
So if I know there's at least a 6, what's the largest possible length of the other sides? Should I just try the ones they gave me? Start at
I
16?
guess. Yeah.
Let's try it.
So
So 16 is the
six,
longest side.
16,
What's the worst possible case?
the worst possible case. Like
Yeah. What's the worst thing that could happen?
it being a trapezoid. I don't know. That's a joke. Uh, I just don't like trapezoids.
I will let the trapezoid lobby know that you are anti-trapezoid.
Um,
I don't think they'll
that
care.
it doesn't work.
Why doesn't it work?
Uh, one sec. Six. That's. Oh, one sec. 22, right? So, that leaves us 10. And assuming we split them equally, because that's the best optimized thing right now.
Mm-hmm. Then it would be,
5 and 5 and
well,
6 plus 5 is not greater than 16. So
yeah, the sum of these three have to be at least as big as the biggest side. Otherwise, they're just going to fall flat on make a sandwich, right? This will be 5, this will be
uh,
6, this will be 5, and that's exactly 16.
so 15 would not make a trapezoid, but um, let's say it's 15. One of the sides will be 6. This, no, this is greater than fifth. What am I
6 plus
saying?
6 plus 5 is,
It's 6 plus 6 plus 5 is I was thinking triangles. Um,
how big is 6 plus 6 plus 5?
that's 17.
And that's bigger than this, right? So is it safe?
Yeah, I think so.
So it's the biggest possible because it was possible.
Hmm.
Okay, great job. It could be a trapezoid though. You said it couldn't. We could have 15. We could put the sixes here.
Yeah.
with the 5 across. It would actually be very short. It'd be somewhere in between here, but okay, our last competition problem. And then we move on to your favorite segment. It's the
What?
game segment.
Yay.
Evelyn keeps track of the
Well,
average number of subscriber additions per day to her blog. If 13 subscribers subscribe to Evelyn's blog tomorrow, the average number of new subscribers per day will increase by 1. If 13 subscribers subscribe to her blog in each of the next 3 days, the average number of new subscribers per day will increase by 2. What is the average number of new subscribers per day?
so yeah, plus 13 plus 13 subscribers in one day to the average makes the average go up by 1.
13 makes the average go up by 1. What does that mean?
Um, that if you take the average, that means the average is below 13. Definitely below 13. Well, yeah, our options are all below 13, right?
Right now, we are below 13 because when I add 13, it's going to increase. What's the best numbers I could use right
Um,
here?
no, but averaging those two isn't quite accurate. Is it? What are the best numbers? Um, I don't
Let-
know.
let's set up a formula.
Yeah,
Okay, what do I want to know?
the current average.
Okay, let's call that n for now. What
So,
what else do I need to know but don't know? What else can I set up as a variable?
how how long she's been blogging?
Okay, so how many days she's been blogging?
Is this gonna be a system of equations?
Maybe, probably.
Especially that we have a n.
Oh, did I give it away? with my variable names? I'm sorry.
I mean, I kind of know. I thought of that before as well, but it being AN kind of makes it even more obvious. I thought of sequences, but yeah. Anyways,
Mm-hmm.
so
So, how do I find the average?
the average.
What's a
Mm,
formula for the average number of new subscribers?
uh, correct me if I'm wrong, but it's like the amount of subscribers versus days for the average number of subscribers per day she was streaming at.
Yeah, so she had a
Yeah.
list of all her subscribers. She got 2 on one day, 3 the next day, 10 the next day, 5, 8,
Oh yeah. And
28, something like that.
add all of those together and divide them by the amount of days she's been streaming.
The number of days, that's A. Okay, so we're going to sum these up, and that's a sigma. Add these up, divide by A. Now it's
And if
now it's the next day.
so, plus 13,
We know that we're adding 13.
and A will be plus 1.
And we're dividing by A plus 1. Is there a way to find this part?
It's the previous day, right?
Let's call that X.
X.
X plus 13, but not just X plus 13. It's how many of these I had, which is A. AX's. Okay?
Mhm.
So let's call the average, the old average, X. So then we have AX plus
Well,
13 over A plus 1 for the next day. And that's going to equal what?
uh, that's gonna equal, we said that this whole thing equals X, or
Yep,
then that's gonna equal X plus 1.
awesome. We've got an equation with two variables in it. Now we need another one.
Um, 13 subscribe to her blog over each. So that's, what's 13 times 3? That is 39. So we have a x
Plus 39.
plus 39 over a plus 3 equals x plus 2.
Awesome. We've got equation 1 and 2 set up.
So we could do -1, -1 on each side to get this to x plus 1 so that we can
So we can
from
set
there
them
get
equal.
ax plus 39 over a plus 3 um is
-1.
Masakao.
No, keep that there.
Uh, I will move it up so I have more space.
I can move it up
Ax,
for you.
whatever.
Too late, Mr.
A
Andy.
plus
Decisions
3
were made.
-1
Equals
um
this
equals
thing.
ax plus 13 a plus 1.
Okay. Now I can get rid of this. For now. We'll bring it back later.
Yeah.
Okay, I need to
So
isolate for either A or X. Which one seems easier?
um I don't know, x, I think.
There's less X's, so yeah. Okay, so
So
let's get rid of this.
yeah, multiply this by both a plus 1 and a plus 3.
Okay,
Only really, only that really only multiplies the top by a plus 3. And
what does the 1
same,
become?
um and multiply the other side by a plus 1. The 1 becomes negative a minus 1.
But you're also multiplying by A plus 3.
Oh, right.
It does not have 1 on the bottom.
So then -1 a plus 1
A plus
a
3.
plus 3. Oh
Awesome.
wow, a quadratic equation.
Ooh, it's almost
Actually,
full
like
circle. Engaging math
actually,
circles.
it's almost like this. I forgot the parentheses.
Mm-hmm.
Well, also look like a quadratic equation.
Sure will.
Almost.
Okay,
Um,
so
and
A plus
a
1,
plus 1
the A plus 3 will cancel out.
ax plus 39.
Okay,
So now
I want to get the X's on their own.
a to not so a squared x plus ax plus 39a
Was 39.
plus 39 minus
A squared.
a squared um plus no minus
Everything's going to be minus because of the -1.
yeah minus 4a minus 3
Equals.
equals a squared x plus 13a plus 3ax
Plus
plus
39.
39. Oh,
What can we eliminate off both
wow.
sides?
Instantaneously, these two, um,
We also have a plus 39
and
on
the
both sides.
39s. 3ax, we can move it to make negative 2x. We can make it positive later.
Negative 2
Oh yeah, ax.
AX.
And 13a, 39,
39A.
uh,
Subtract this.
minus, the 26.
26A. Minus A squared minus 4A minus 3. All of this
Oh,
became
4a
0.
minus
Minus
4a,
4A, yeah.
so we can make this 22a
Mm-hmm.
minus a squared minus 3 equals 0. So looks like it needs rearranging, so
Well, let's clear off this top here. I'll move this up to the top.
for that. Okay. So negative a squared. Oh, I see what we might need to do. Um, minus 20 plus 22a minus 2ax minus 3.
Okay.
We're solving
We need
for
to get X
x.
on its own, so let's put that on the other side. And that makes it positive.
Mm-hmm.
So we're going to divide this by
A 2a.
2A.
And we get x equals,
Well, this ugly, ugly thing.
yeah,
And we would substitute that back into one of the first two equations and do a whole lot more algebra. But for the sake of our audience's sanity, once we substitute the x in, we'll solve for a and find that a is 3. So what does x have to be?
if a is
Putting
3, then
3
that
in here.
is negative 9 plus 66 minus 3 over 6. So this should be quite easy because if
66
we
minus
combine
12.
those, that's 60, and 60 over 6 is 10.
Close. 9
No?
minus 366.
Oh, wait, no, I was canceling Like I was
It's okay.
subtracting
We
3
haven't
from
had a break
9.
like normal.
Yeah, no, that would probably be 9 because that's the closest answer. And yeah,
9. X equals 9 is correct. AMC 10. No joke. Tough one. Okay, you've had such a good time. Now let's have a better time. Let's get to game time. Spot 6 differences.
60. I should probably choose a better color. 6. Nope, that there's blue. Yeah, that works.
16 and 19.
Yep. There is this one's missing.
An extra sign. A red light camera disappeared.
The umbrella.
The umbrella turned into a newsstand or something. 2 differences left. My clue is light. Yeah, there she goes. The
I
headlight.
noticed it. I noticed it like just before you said the clue. So one more.
One more change. My clue is window.
Mm,
Yes, this window became very dark and full of shadows. Okay, one more. It's got a bit of math in it, but it is fun. I sometimes run, but I can't walk. What am I?
river.
A river is a good guess. To figure it out, we have to highlight multiples that are next to each other. So 5, 25, 80 are all multiples of 5. What other multiples of 5 are there? 175, 135.
That's not a letter. Okay, I
Not a
guess that
letter
will be.
yet.
Hmm.
Not a letter yet. Okay. We also have multiples of 2 over here.
They seem to be on their own.
Any more
Do we need to
multiples
have
of 2?
a way? Right.
All the way down and across. Looks like it ends in what letter?
E.
E. Okay. But now we got to find the multiples. Anything with equal multiples next door to it, another thing.
Mm.
I see 9 and 18. Do you see anything else I can add to it?
Uh, 118. No, but does this count?
It will if there's another one here that shares.
Well, let's see.
Is 71 is not divisible by 7, but is 59?
I don't think so.
No. So diagonals don't count. They have to be
Yeah,
adjacent to each other.
okay.
What other multiples are there that could go into 9 and 18?
3, right.
3.
3,
3. 3. Any other multiples of 3 here?
one sec. Isn't 7 in both of these? Yeah.
Yep. 7.
What, uh, what other multiples of 3? Uh, I believe 57. Yep.
57 gets added on.
That's a N.
Looks like an N now, for those who can't see it. Fancy N. More 7s here. Any more 7s nearby?
Mm, no, I don't think so.
Okay, let's find another multiple. Eleven's there. I'll go with purple.
Wait, yeah, right?
11 times?
12, right?
12.
Yeah,
Mm-hmm, mm-hmm.
I swear this keeps trolling me. This is a multiple of 7, and like this is, but they aren't connected.
Aren't they connected?
Let me check that one, but I don't think so.
63?
Oh, I guess they are.
154?
154 is, for some reason, I think I remember that. I don't know why. I'm just gonna assume 91 is too. I forget.
It is. It's one of those
Okay.
primes that you think is, it's one of those numbers you think is prime, but isn't because of 7.
7 is weird.
Because it's 21 higher than 70.
And oh no, nose.
Nose! These two are also
Uh,
together and with 17, and these are together with 13. And we get nose. I sometimes run, but I can't walk
Well, that nose seems to be walking.
or running. Hard to say. Okay, Anna, thank you so much for joining us. I hope you had a wonderful time today. I know I had a good time with you, doing some math, having some fun, getting to know you better. Would you be willing to join us again in the future?
Yeah,
I didn't hear you.
yeah.
Awesome. Okay, I hope you have a great weekend. Enjoy the 4th of July, and we will see you in the future.
Bye. See you.
Bye, everybody.
Bye, chat.
Bye, chat.